Hi everybody, in this video we will talk about ions and oxidation numbers and oxidation states. So we have been talking about valence electrons, and I have been telling you that the chemical behavior of the element depends upon the valence electrons. Okay, so one more time, let's do valence electrons, group 1, group 2, 3 to 12, then we have 13, 14, 15, 16, 17, and 18. So these are the valence electrons. Um, 1, 2, 3, 4, 5, 6, 7, and 8. Well, today we will talk about octet rule. The word octa means 8. So we call it rule of 8. That atoms are most stable. Okay, means they feel better, they're stable when they have 8 valence electrons. Okay, so they all like to have 8 valence electrons, just like noble gases. So if you look at noble gas, this is a noble gas, right? So this group is called noble gases. So they have 8 valence electrons, and everybody here like to have 8 valence electrons, and that's called octet rule, or the rule of 8. Now what is the option? The option is to gain or lose to get 8. Okay, so the elements who have less number of valence electrons, like 1, 2, or 3, the only option they have is to lose electrons, um, and get 8. And those who have 7, they can gain 1, gain 2, and gain 3 to get 8. So let's look at the example of sodium. What am I really talking about? Sodium has 2 electrons here. Sodium has 8 electrons here. And sodium have 1 electron right here. You know, sodium is sitting right here in period 3. So sodium has 3 energy levels. Um, 1, 2, 3, and this is the valence shell for sodium. These are the valence electrons for sodium. This is how you do the dot diagram of sodium. Sodium has only 1 valence electrons, and the dream of sodium is to get 8. So who's going to give sodium 7? Nobody. So the option for sodium is to lose this electron. When it loses this electron, this energy level is gone. So what is sodium left with is 2 here and 8 here, because this energy level is gone. Sodium lost it. So when sodium loses an electron, okay, it loses the whole energy level, and this one becomes valence shell, okay, and it has 8 valence electrons. So this is how sodium can fulfill its dream. So anybody who has less number of valence electrons, 1, 2, or 3, they're going to lose, okay, and their charge is going to be positive 1, positive 2, positive 3. Anybody who has higher number of valence electrons, like 7, 6, or 5, they will gain 1, okay, they gain 2, they gain 3. How about group 18? They don't need to do anything. Their charge is 0. So these are called oxidation states or oxidation charge. Okay. So if I ask you, what is the charge of sodium? So sodium is in group 1. So you will say the charge for the sodium is +1. What is the charge of calcium? Calcium is in group 2. So the charge for calcium is +2. Fluorine is right here. So the charge for fluorine is -1. Nitrogen is here, so the charge for sodium is -3. So go ahead, you need to be able to draw this. I mean, I will do it one more time for you. Let's erase this whole thing so that you learn how to do it yourself. Okay, let's draw the periodic table again. Um, so here is the periodic table. This rule only applies to main group elements. So we have group 1, 12, 3, then we have 13, 14, 15, 16, 17, and 18. We have noble gases. Okay, 1, 2, 3 to 12. So let's do the valence electrons first. 1, 2, 3, 4, 5, 6, 7, and 8. These are called valence electrons. Okay, so everything here is called valence electrons. Now, as I said, we have a dividing line here, okay? So these are all metals, and above it is the non-metals. So metals are going to lose the electrons, okay? All metals will lose electrons. That process is called oxidation, and all non-metals will gain electrons, and that process is called reduction. So when they lose or gain electrons, the charge they're going to get is, this is +1, +2, okay, +3, -1, -2, -3. They don't need to do anything. The charge is 0. And this can go either way, -1 or -4 or +4. Okay, but usually it is +4. So we have, these are called oxidation states. So whatever I gave you just now are called oxidation states. Okay, these are called, these plus minuses are called oxidation states. So oxidation state is the charge of an ion needed to have same number of electrons as noble gases. So what is an ion? We use the word ion here. Okay, ion means a charged atom. Like sodium is an atom when it has 11 protons, okay, and 11 electrons, no equal number of positives and negatives. But when sodium loses an electron, it has 11 proton and 10 electrons because it has lost an electron. So it has more positives than negatives. Okay, so since it has more positives than negatives, it has a +1 charge. And now it is called an ion. So if it has a positive ion, that means it has lost electrons and it's a positive charge. Those are called cations. And the gain electrons, that's called negative charge, are called anions. So all of these that I was writing here, all the negatives, okay, are called anions. Anions means negative ions. And all these which are positive, okay, are called cations. Cations means positive ions. So we need to know that any charged atom is called ion. Charged atom. It could be positive, it could be negative. So positives are called cat, like cat ions, and negatives are called anions. Okay, so you have to understand these terms and oxidation numbers. So how do you predict oxidation states? I've already explained you that. Metals for positives, all these are called metals, okay, and these are all non-metals. So non-metals gain electrons and form negative ions, and metals lose electrons to make positive ions. So they go through oxidation and they go through reduction. Okay, so the charge here, the number of charge comes from how many electrons are lost or gained. So all of these are going to lose 1, all these are going to lose 2, then lose 3, gain 1, gain 2, gain 3. They don't do anything, and they can lose 4 or they can gain 4. So this is how you can predict the oxidation numbers. You have to memorize these oxidation numbers. Okay, +1, +2, +3, -1, -2, -3. This could be +4, -4, and this is 0. So these are the oxidation numbers or the charges. So for example, sodium. So sodium has 11 atomic number and 23 is the mass number. So sodium is in group 1. So sodium has 11 protons. Okay. So sodium has 11 protons. Come on, what's wrong with it? So sodium has 11 protons. Okay. Electrons in the neutral atom is 11. All right. Electrons oxidation number is going to be +1. Electrons in the ion are 10 because it has lost an electron. So what happens is it has lost an electron. So that's why it has the oxidation +1, means lost an electron. So the electrons left are 11, but the number of protons will never change. Okay, so the number of protons always remain the same. So don't change the number of protons. So number of protons is still 11, but electrons are 10. That is why you have an extra protons compared to the electrons. That's why it has a positive one charge. And that loss of electrons is called oxidation. Okay, so that loss of electron is called oxidation. If anyone gains electrons, like right here, it is called reduction. So gain of electron is reduction, loss of electrons is oxidation. Uh, so this is how you do carbon. So go ahead and complete this table, and then we will go from there.